हेलो गाइस। आज हम वापस लाइव आ गए हैं और हमारा अभी वी आर गोइंग टू डू द टॉपिक ऑफ कॉची इंटीग्रल थ्योरम. We had already seen this topic previously, and we are going to see detailed versions of the same. Okay, so let us see how to handle questions related to Cauchy integral formula uh, today. So we are going to see some different versions, a difficult version of the same. Okay, uh, kind of the questions which are there always, always they are there into the, you know, our exams. So let us see how to handle those kind of questions. So I hope I'm audible to all of you. Connection is excellent as it is showing to me on the screen on my settings side. So that is what I see there. Yeah, so good evening to all those who are there, and good morning to all those who are on the other side of the globe. Yeah, so let us start with this its part. If you have any questions or any difficulties, let me know. Yeah, so let us begin the main topic for which we have gathered. And I see right now there are hardly any views or hardly any viewers on the live session, but we will continue as the people will join in, so we will get to know more of the thing. So let us begin over here with the kind of questions today that we are supposed to take. Now I take up the following questions for our better understanding on Cauchy integral formula. So let us see how to handle them. See, the question that I am first, I'll just revise quickly through the main formula. That the main formula of the one that we are going to use the formula in the solving of the question is integration f of z over z minus z naught dz over some curve c is equals to 2 pi I times f of z naught. This is the basic version of the Cauchy integral formula. Okay, Cauchy integral formula. Now the, and here what is z naught? Z naught is inside C. The next formula that we have is f of z over z minus z naught whole raised to n dz. If we do, then there is something nice happening here. It is 2 pi I divided by n minus 1 factorial. Okay, that is what we have. And after that, what do we do here? The next part we have is, there is that many times we have to take the derivative. Okay, we have to take the derivative of the function over here. Okay, we have to take d by dz of n minus 1 n minus 1 of the function, okay, d by dz, I mean to say the n minus 1th derivative you do of the function and evaluate it at z equals to z naught. So you will get your answer. So this formula is the rather a general version. So Cauchy integral formula for derivatives. This is very popular for derivatives. Okay. Now let us move ahead with an example in the same topic. If you can hear me, please let me know that I am audible. Is there any sound or background sound bothering? Then please let me know. If at all it is possible to adjust from some settings, I would do that. Am I audible to you, those who are there online or those who are there on our live? Please let me know in the chat section that I'm audible, and then I can safely help you out with the questions that we are going to take up. Hello. Yeah, yeah, we can see that fine. So now we'll go for, yeah, fine, we are audible. Now we'll take up some small example so that how to use Cauchy integral formula. Now the case is going to be slightly different version that we are going to see. In our last video we had seen easy examples. Now we will see some difficult examples. Let us see how to handle them. So the first example I'll take over here is the following. Mm, let's do this one. Yeah, we'll do this example. Integral sine 2z divided by 6z minus pi. We had done a similar, but now thing is there is a power 3 over here. Then what to do in such a case? Dz, where C is the circle, z equal to 3. Okay, so how to handle this example? So first thing first, we write I equal to integral sine 2z divided by 6z minus pi cube dz. You write this, and after this what you do is, see, we want always in our denominator in the following format. The format over here is this. I would like to have my denominator in the format of z minus z naught. So you can see that the coefficient of z is always 1. Okay, so what I need to do now, this 6 I don't want in the given integral. So what I can do, I can take 6 common. So when I will take 6 common, I will get in the numerator, I will get whatever I have. Sine 2z will remain the way it is. There is no change there. In the denominator, when I take 6 common, it is cube is there. Okay, so it will become 6 cube in the denominator coming outside, and here I will get z minus pi by 6 whole cube dz. Okay, this is what I will get. Now 1 upon 6 cube will remain outside, and I will have to find the integral z minus pi by 6 whole cube dz. I'll integrate the following. Okay, I'll integrate the following bracket which I am putting inside the blue bracket. Okay, so this is the bracket that I will be now focusing upon. So now when I compare this part with the given formula that we had written, so by Cauchy integral formula I can compare and write. One more important thing is there, I have to remember here that this z0 should be inside the circle, so we just check that, and it is very obvious here. Here we write here z0 is equals to pi by 6 mod of z0. When you calculate, it is mod of pi by 6, which is equal to pi by 6, and this is less than 3. Okay, are you following this? So what we do now, we claim here that z0 is equals to pi by 6 lies inside the circle C. Okay, inside the circle C, and therefore we are now going to write here n is equal to 3. Okay, the n is equal to 3. Which 3? This 3. Okay, the in the denominator that you can see in the power, that is 3. Now, and f of z is equals to sine 2z. It is sine 2z. Now we calculate that many derivatives. So how many derivatives we will need to calculate? 2 derivatives. How do we come to know that we have to calculate 2 derivatives? N minus 1. Okay, reduce it by 1. So here I am going to calculate 2 derivatives. So therefore f dash of z, what is the derivative of sine 2z? We have to calculate. So sine derivative is cos 2z into 2. Again you calculate the derivative f double dash of z, that is going to be minus of sine 2z into 2 square. Okay, now this derivative is to be evaluated at the point z0. Therefore f double dash evaluated at z0 is nothing but minus of sine 2 pi, or you, if you want to write, you can write like this way, that would be good. First, since you are replacing z by z0, so in entire equation you replace z by z0, so z0 into 4. Okay, here it will come 4. 2 square has become 4. Okay, now we substitute the answer for f double dash of z0. So the z0 is pi by 6. Here we write minus of sine 2 into pi by 6 into 4. Are you getting that? Okay, so minus sine pi by 3 times 4. Sine pi by 3, how much is sine pi by 3? It is going to be 60 degrees. Sine of 60 degree is root 3 by 2. So our answer here is minus of root 3 by 2 into 4. So my final answer here is minus of 2 root 3 for f double dash of pi by 6. Therefore, by Cauchy integral formula for derivatives, I will have the value of that bracket over here. See, it is sine 2z divided by z minus pi by 6 whole cube dz is equals to 2 pi I multiplied by f double dash of pi by 6 divided by n minus 1. Yeah, n minus 1 factorial we had to do. So n minus 1 factorial is going to 2, rather I'll write here in a detail 3 minus 1. Okay, so 3 minus 1 factorial. So we substitute now all that, and here we will get 2 pi I 2 pi I multiplied by minus of 2 root 3, okay, divided by 2 factorial. This is the answer here we get. So that is minus of 2 root 3 pi I is the answer. 2 and 2 factorial will get cancelled. Now the final answer, therefore I is equal to, the I that we had is 1 upon 6 cube into minus of 2 root 3 pi I. Okay, so we will get this answer here. Hello, hello. So we have in chat someone. Hello. Yeah. So now here we can simplify this answer a bit, and we can write down. So the answer will be, so we just have to simplify this. Yeah, so this is going to be root 3 over 108 pi I, and here there is minus sign. Okay, I hope you followed this. Please let me know if there was any difficulty. If there was any problem, then we will sort it out. Otherwise, we can go for the next example. This was our first question, and we saw a nice complication that is coming into the solving part. Okay, so can you see that sound is not coming? What sound is not coming? Hello, can you hear me? Hello, hello, hello. Let me see. Can you hear me? Am I audible? Hello. Let me check. My mic is already there. Hello. Hello. Ah, it is there. Sound is coming. What is the problem? Is there any other problem? Anyone else? Hello, am I audible? Please let me know, am I audible or not? Yeah, I am audible. Yes, I am audible. Yeah, maybe at your place your some network issue could be there, but I am audible. Yeah, thank you. I was little bit confused because my system shows that I am audible. Yeah, okay. So now, have you followed the topic that followed the example that we have done? Have you followed the example that we have done? Please hit like in the comment section, or let me know that the example is clear so that I will take up another example. Hello, could you please let me know in the comment section that whether the thing is working properly? Hmm. Now, this was the example that we saw for Cauchy. Yeah. So for Cauchy integral formula for derivative, this is the example that we have seen. Now let us take up one more similar example in which such a kind of thing has to be done, and all these kind of examples you will need this practice, that whenever the denominator is having this kind of pattern, then we can do the following way out. Then there are other cases also. So let us take up another example. Now this example is slightly different and slightly, there is a lot of working that is going to be required for doing the part. Let us see how to handle it. The example is integral z sine z divided by z minus pi by 4 whole to the power 5 c dz, where c is z minus pi by 4 equal to pi. This is a good question, and see, all it's a very non-trivial question, and you just have to learn to understand the numbers carefully. That's it. Okay, so how do we handle this? Let us see now. Now, as we see, the first condition in using Cauchy integral formula, uh, that is, we want z to be alone. So we wanted z to be alone. So here z is alone, right? That means, what I mean by z is alone, it has coefficient 1. So here coefficient of z is 1, okay, in the denominator, and it is of the format z minus z naught. We have got that. So here we now check here z naught is equals to pi by 4, okay. Circle is z minus pi by 4 equal to pi. So what do we do? We now check z naught minus pi by 4. So that is going to become pi by 4 minus pi by 4. Okay, and that means this is mod of 0. Mod 0 is 0, which is less than pi. Therefore z naught lies inside C. This is the thing that we have detected. Now we are in a position to write the other part of the formula. So what all details that we need are, the details that we will need is z0 we have already found, n is equals to phi, okay, and f of z is equals to z sin z. This is now going to be a nice question of lot of integration going to come into the picture. So let us see how to handle. So here first let us write the formula and let us understand what all things are required. So this is a question I. So by Cauchy integral formula for derivatives, we will have integral f of z, z minus z naught to the power n dz is equal to, what is it going to be? It is going to be 2 pi I over n minus 1 factorial with d by dz of how many times we will have to take? N minus 1 times, right? N minus 1 times the derivative of f of z, which we will evaluate at z equal to z naught. This is the formula that we have. Now comes the main part. So this, when you substitute, it is going to, LHS is going to get converted to I. What is going to happen over here is this: 2 pi I n minus 1, so phi minus 1 factorial, okay, and we will now have how many derivatives to be calculated? 4 derivatives to be calculated for function f of z, that is z sin z, okay, at z equal to pi by 4. We will have to evaluate it. Let us see how to do this. So now first we will go for calculation of the 4 derivatives, okay. So let us see how to calculate that. So f of z is z sin z. Now those of you are not comfortable with derivative, you will get the practice of that over here. See, you need to use UV rule over here. UV rule, or the product rule that we generally call it. So f dash of z, the first derivative, is z into sin z, derivative is cos z plus the next derivative will be sin z multiplied by 1, okay, derivative of z is 1. So here you get that. Now you do the double derivative. Double derivative of f of z is what? Sorry, you take the derivative of the f dash of z, so it will give you z cos z, derivative is minus of sin z plus cos z into 1 plus sin z, derivative is cos z, okay. So this is what you have got in the derivative notation. So if you simplify this, it is minus of z sin z, okay, plus 2 cos z. This is the derivative that you will get. I hope you are getting the second derivative. Now while calculating the third derivative, you do little bit smartly. You have already calculated something and that will help you. Now when you calculate the third derivative, what it is going to give you, it is the derivative of z sin z, which we have already calculated in the first one. So it is just put the negative sign to z cos z plus sin z. Okay, and then there is 2 times the derivative of cos z derivative is minus sin z. That is what you got. Now there is minus of z cos z minus sin z, and then there is already minus 2 sin z. So this will give you minus z cos z minus 3 sin z. This is the answer. The next here is f fourth, if you want to calculate like this way, or you can put 4 dashes, that is fourth derivative of f of z. What it is going to become, when you calculate the fourth derivative, you have already calculated now the derivative of f z cos z. So otherwise let us do it again, not a big problem. So minus z into derivative of cos z is minus of sin z. Okay, and then the derivative of cos z, we have written minus sin z, and here it will be cos z times derivative of minus z. So derivative of minus z is going to be minus 1, and minus 3 times sin z derivative is cos z. Okay, so finally our answer here is going to be the fourth derivative. When we calculated f4 dashes, when you calculate, you get over here is z sin z. Okay, and then there is minus cos z minus 3 cos z, so that is going to be minus of 4 cos z. This is the fourth derivative of z sin z. I hope you have followed. Please let me know if you have followed, then I would be very happy. And if there is any difficulty in this, I would be happy to help you. So let me know any difficulty is there, otherwise we can proceed ahead. Have you followed the derivative? Please let me know. Please let me know the derivative, whether you are able to understand it or not. Yeah. So it is minus of cos z minus of 4 cos z plus sin z into z. Have you followed? Please let me know in the comment section. Hello. Yeah. Now we proceed further. I believe people are still calculating their derivatives. It's okay, not an issue. So this fourth derivative that you have calculated, we now evaluate this fourth derivative at the point z0. So that point z0 is z0 sine z0 minus 4 cos of z0, and that z0 over here in our example is pi by 4. So here it will become pi by 4 sine pi by 4 minus 4 cos of pi by 4. Now pi by 4 will remain pi by 4 only outside, which is there. Okay, I'll write it here. That is not going to change. There is no change in pi by 4, but sine pi by 4 can be changed to, this will remain pi by 4, this is 1 by root 2, and this is 4 times 1 by root 2. Okay, so here you have got the answer. So if at all you want to take any common or something, maximum you can write this here in this manner: pi minus, if you take it in the numerator and denominator, then this will become pi upon 16, pi minus 16 over 4 root 2. This is the simplified answer for this. Okay, now you go next over here for Cauchy integral theorem that we have written. So the value of I will be, so the value of therefore I equal to 2 pi I divided by 5 minus 1 factorial into pi minus 16 over 4 root 2. Okay, and now 2 pi I, when you do, so 2 and this gets cancelled, some cancellations will happen. So here you can write, this is 4 factorial. So 4 factorial is going to be how much? 4 into 3 into 2, that is 24. 24 or 24 factorial times pi minus 16 4 root 2. So this is going to be nothing but pi I times pi minus 16 over, this gets cancelled, so 2, here it will be 48 root 2. So this is the final answer. That's it, nothing more on that. Okay, I hope you got this example. Now these were the two basic examples that were to be dealt with when there is a power in the denominator. Now there is one more kind of example in which you need to think a bit and do very carefully, and that example is this one. Let me help you how to handle with these kind of examples when there are more than two terms in the denominator and both of them are in the circle. So you can write down that kind of example, and that will help you to crack down various other questions also. So let me help you out with that example. Let me take up some easy one so that you digest the whole thing. Let us do the first example, which is very easy and pretty much straightforward. Yeah, hello, have you followed this example, those who are there online? Okay, fine. Okay, Is there any uh, difficulty in the following examples that we have seen, or we can proceed further? Okay. Now let us take up the following example in which things are slightly different and they are slightly new for you. So again, let me take up this question here. We'll take up the following question that helps you to, build your understanding on the following topic. Yeah, let us do this kind of question where integral 7z plus 2 7z plus 2 over z minus 3 over z minus 4. Okay, this is the question, and dz where mod z c is mod z equal to 5. Now comes a difficulty, how to handle this kind of problem. So in this case, what you are expected, let us see. First you find out the question, or the points at which the denominator is becoming 0. So here let z minus 3 z minus 4 equal to 0. Therefore z is equals to 3 and z is equals to 4. You can get that two values, so I'll call this as z1, I'll call this as z2. Now it is very obvious that z1 and z2 both lie inside C, right? Because I don't think there is now anything to check. 3 is less than 5, 4 is also less than 5. So both lie inside the circle C. Now when both the points are inside the circle, we have not seen how to handle it. Okay, now comes very important technique, is that when two points are inside the circle, I'll write here two points are inside circle. So whenever two points are inside the circle, you must do partial fraction. So let us do the partial fraction. So how to handle the partial fraction, let us consider this. So 7z plus 2, and now the factors over here you can see they are distinct. So how to handle that? Z minus 3 z minus 4, we write here a upon z minus 3 plus b upon z minus 4. Okay, so what do we do is 7z plus 2 is equals to a times z minus 4 plus b times z minus 3. We now put arbitrary values but a smart value. So we put z is equals to 4. We will get 4 sevens are 28 and 30. Okay, 30 is equals to b times 4 minus 3, that is 1. So here you get b value equals to 30, and you put z is equals to 3, you will get 7 3s are 21 plus 2, 23. 23 you get here. So 23 is equals to 8 a times minus of 1. So a is equals to minus of 23. This is what you get. Now therefore what do you do here? So you write down the partial fraction 7z plus 2 over z minus 3 z minus 4, okay, which is equals to minus of 23 over z minus 3 plus b is going to be 30 over z minus 4. Now the integral property will allow us, so when you take integral here, so 7z plus 2 over z minus 3 z minus 4 dz will allow you to write this a with minus 23 divided by z minus 3 plus b equals to 30 divided by z minus 4, okay, with dz. Now you can see here that your denominator, okay, your denominator has got converted to a single linear factor, and now this can be directly written in terms of the answer. So minus 23 integral over the curve C, when you are doing, don't perform the regular integration. This is not regular integration. Here you are supposed to write the answer with the help of the formula that we have learnt for Cauchy integral formula, okay. So that is what you have to write here, dz over z minus 4. So answer here will come minus 23 into, here your answer is going to be 2 pi I, and whatever is the function in the numerator, here the function is 1, so there is not a difficulty, so it is 2 pi I only is the answer, and here the next answer is 30 into 2 pi I. So this is what is going to give you. So 2 pi I taken common, you get 20 minus of 23 plus 30, that is 7, so this is 14 pi I is the answer, okay. This is how you get this part. So when there are partial fractions, you have to be very careful. Partial fraction, when there is there, this is one basic and a very easy example that I have shown you over here. There are further complicated examples also. Let us see how to handle them. But first you learn this easy example, that when there are 2 points are there which are in the given question and both the points are inside the circle, we should use partial fraction method to calculate the answer. Okay, so this is one very important question that I wanted to do with you guys. Now there is one more important question on this same part. Let me help you out how to handle this. There can be more terms also in the denominator, so according to that you have to adjust your value and get it done, okay. Let us see how to handle this. So the question here is this. Yeah. So the question is integral 4z upon z minus 1 z plus 2 the whole square dz. C, where C is mod z equal to 3. Okay. Now here when you let denominator, so you can do, I'll give you one very important note over here at the end of this sum, and this sum is the last sum that we will be seeing in our Cauchy integral formula, so that the whole concept of Cauchy integral formula gets covered through this series of lecture. And then if there are any difficult questions, I will also like to share those. Then let's see if there are any. I don't think so there are much, but this is the general pattern that is followed. So now when we are doing this kind of question, we have to be very careful. So first thing is, let z minus 1 into z plus 2 the whole square equals to 0. So z is equals to 1 z, and then there is minus 2 repeated 2 times, not a problem. But z1 is equal to 1 and z2 is equals to minus 2. Okay. So again both z1 and z2 lie inside C, right? It is now, see, I'm not doing the basic verification here because these are simple numbers. If they are complicated complex numbers, then you can check the verification whether they are inside C or not. Okay, so z1 and z2 lie inside C. This is very easy to verify. You just take the modulus of z1, that is 1, and modulus of minus 2 is 2, which is less than 3. Okay, both the answers should be less than the radius. Then you check that whether they are inside, so they will be inside the circle. Now what we do is partial fraction. So 4z upon z minus 1 z minus 2 the whole square. How do we handle this? So this is handled in this manner: a upon z minus 1 plus b upon z minus 2 plus c upon z minus 2 the whole square. You can calculate the partial fraction here. So you will get 4z is equals to a into z minus 2 the whole square. Here you will get z minus 1 z minus 2, oh sorry, z plus is there, we'll put plus, so z plus 2 the whole square, and here c times z minus 1. Okay, so we now calculate by putting the calculate values of a b c by putting some arbitrary choices for z. So we first put easiest choice, z equal to 1. So the moment I put z equal to 1, I get 4 is equals to a into 9. Okay, and then the other terms go 0. So here I'll get a value is equals to 4 upon 9. The moment I put z equal to minus 2, put z equal to minus 2, what do I get here is minus of 8 is equals to a times this minus 2. Yeah, this goes 0, this goes 0. So c into minus 2 minus 1, which is equals to 8 over 3 c. Okay, c value is this. This is what you would get. The next value is for b I have to get, right? So I'll put a and b both, sorry, I'll put z equals to 0. That's very easy choice that works over here. So put z equals to 0. The moment you put z equals to 0, you will get 0 is equals to a into 4 plus b into uh, wait, b into here, you would get here something. This is not square, okay? This is not square. This is going to the moment what you need to do is you multiply the denominator into the denominator of LHS to each of the numerators in the RHS. You will get your answer. So this is not square here, okay? um, yeah, and so here the moment I put z equals to 0, here you get minus of 2 and c becomes minus of c. So 0 times a is already we are aware, so a is 4 by 9 into 4, and here we already know that it is minus 2b and c is 8 by 3. So simplifying this, you get 0 equals to 16 by 9 minus 2b, and that c is 8 by 3, so I can write this as 24 by 9. 8 3s are 24 and denominator will get you 9. So you have here it is 2b is equals to 16 minus 24 over 9. Okay, and so b is equals to 8 minus 12, so minus of 4 by 9 will be your answer, right? So this is the value for b that you get there. So we got the value of a, b and c. So let us write down the partial fraction now. So here you have 4z divided by z minus 1 z plus 2 the whole square equal to a. The a value that we have got is 4 by 9 times 1 over z minus 1 plus b value we have already got here in the above part is minus of 4 by 9 into 1 over z plus 2, and then c value we have got is 8 by 3, that is 1 over z plus 2 the whole square. Now when we integrate here, let us see what all things we get. We now go for integration. The moment we apply integration here, so therefore integration of 4z over z minus 1 z plus 2 the whole square is 4 by 9 integration, you do that dz, 1 over z minus 1 dz. Here it is minus of 4 by 9 integration 1 over z plus 2 dz over the curve C, and here it is 8 by 3 integration 1 over z plus 2 the whole square dz over the curve C. Now the first integral answer, the first answer for the question here, you will have 4 by 9. times it, because that z1 is inside the uh, curve, the z minus 1 is inside, right? So your, and the numerator is f of z is 1, so you have 2 pi I coming into the picture. The next one, it is minus of 4 by 9, and here you have 2 pi I again coming into the picture, so here you will have 2 pi I. Okay, yeah. So let me just see, like I have not made any mistake, right? mm, C, yeah, C is 0, 0 is minus 1, yeah, we get that. Yeah, so this value we get, and now, so 8 by 3, here what we will get now, because the function is 1, okay, so this is 2 pi I, but there is a repeated factor is there, okay, and that also you need to remember, it is z minus z naught, so that is 2 pi I and n minus 1, so 2 minus 1 we have to do factorial, and the first derivative of the function f of z, and that function f of z, f dash of function to be evaluated at z naught. So I'll show you that answer. See, 2 pi I, the this portion answer is 0. 8 by 3 into 2 pi I divided by 1 factorial. Okay, now into f dash of z. What is f dash in that case? First, firstly try to understand what is f of z in this case over here. Okay, here f of z in this portion, okay, I'll write with yellow now because this is slightly important part. In this portion f of z is going to be 1. If I take f dash of z, that is 0, and f dash of z evaluated at the point which is inside the circle, that is z2, z2 is minus, that is obviously going to be 0 only, the derivative is 0, so that answer you evaluate at any point, that is going to be 0, so here it is 0, so my final answer is 0 plus 0, answer is 0 in this case. This is very important, here you can take z2 over here. Okay, so please remember this part, very important. So this was one very important example that I wanted to deal with you guys. You can try the following question. uh, uh, I hope you would understand the importance there. You can, so integral z cube plus z divided by 2z plus 1 the whole cube dz over c, where c is mod z equal to 1. This is what is the question, and you have to do this using Cauchy integral formula. Okay, and second, you can also try this example, which is integral phi z dz over z plus 1 z minus 2 z plus 4I, okay, over the curve. You can try with the curve mod z equals to phi. C is mod z equals to 5. The answer for this will be 0, and the answer for the above one, you would get somewhere answer is minus of 3 pi I over 8. Maybe some, if you get some different answer, let me know in the comment section. I would be very happy to guide you on that, but please let me know the answers. So we are done with the question. Now I have one very important note over here, a safe note, whichever whenever the question is there. Okay, very important, I'll write here, important. Okay, now the first thing, all questions that are there, mostly all questions of type, of uh, all questions of type, when integral, which is there, whichever we have done so far. Okay, all questions that are done so far can be solved by Cauchy integral formula, as well as Cauchy residue theorem. Now, whenever given a chance to solve, okay, I would suggest you to do Cauchy residue theorem. Okay, this is one very important thing. Whenever given freedom to solve, whenever given freedom to solve by either method, choose to solve by Cauchy residue theorem. Because why it is this, because there are certain special cases you may not be able to handle in Cauchy integral formula. Hello. Yeah, so what is very important in this, what is extremely important is that whenever you get the freedom to solve the question of by Cauchy integral formula or Cauchy residue theorem, go for Cauchy residue theorem. Cauchy residue theorem method is more safe. Okay, the Cauchy residue theorem method is the most safest one. You won't go wrong in choosing the function. Okay, remember, another important thing is there, that in Cauchy residue theorem, in Cauchy residue theorem, okay, your f of z is the function, is the full function, okay, full function under integration sign. Okay, whatever is there, numerator upon denominator, okay, numerator over denominator. But in Cauchy integral formula, you need to choose the function f of z, okay, So be very careful. So this is all on my side for this topic, and I hope you are able to solve all the kind of questions with this knowledge that I have imparted on this live session. And this is just all there, in different books and different series across so many uh, mathematical uh, you know books that are there, mathematical libraries and etc. So you please study them thoroughly, and I hope this will benefit you. If you have any doubt, please let me know. I would be happy to help you on this, and we are done for the day and the topic. So Cauchy integral formula and Cauchy integration, uh, Cauchy residue theorem, as far as the topic detail is concerned, this is the minimal that is can be done. That's a very far topic, and that's kind of a very easy topic. Maybe we may do, we may not do, because that is the way it is there for engineering students. It's very easy. So whatever can be done is not much on that. But if you have to do for a pure mathematical perspective, it is, yeah. Then I can think of doing that, because there are a lot of difficult, rigorous proofs in that which are worthy of understanding. But from solving purpose, it is very easy topic. Yeah. So uh, vector space topic, right? Vector space is a very easy topic, and if people need, and if that there is a demand of time, I'll do that. But otherwise, I think that's a very easy topic. But from BAC children point of view, it's a very nice and intelligent topic. It is very good topic for machine learning students also. You need to know that topic in great detail. We'll see that later on, but right now Cauchy integral formula, we have only this much, and I hope you benefit from this. So this is all that I have to deliver to you on this topic right now. So if you have any questions, you can ask me, and otherwise we will wind up this short live session that we had today. Nothing to ask, or nothing to share or something. So please hit like button and let me know in the comment section. Thank you. Please hit like, share it with your friends, those who find this topic useful, and till then keep solving good amount of mathematics. Yeah. So we will end this session. Okay. No, we have to end it. There is now nothing more to be delivered. Thank you.